think this goes back to, maybe the model here is that you have a stateless database or a stateless device top with a stateful engine on the bottom, which essentially is implementing policy that you're getting from that device. Yeah. So it's really, and the policy is not necessarily simply an LCR route. It could be a set of routes, it could be more sophisticated, including things like, based on, say, a regex expression, manipulations on the numbers themselves. So the SBC actually is very good in real time making those kinds of decisions and actually, affecting the call flow that way based on policies that it's getting from, an enum server, for example, right? What I've seen essentially is, enum is a good example of this, where you have different types of implementations. One where it's very simple, where it essentially returns a domain address, and then the SBC actually has to make some routing decisions based on the domain address, with a calling plan. That's kind of a hybrid model. A more pure model is the enum server responds with a set of routes or regex expression. I can't say that. And essentially, it just uses its ability to manipulate the calls in real time, keeps the call state and so on, but it doesn't add any more logic to it than that. You see what I'm saying? It gets the policy and implements the policy. It's as simple as that.
Yes. So I would look at it in terms of really the protocols that we use to establish the call in the first place, or that association between endpoints. The protocol of choice in voice over IP is quickly becoming SIP, session initiation protocol. And within that protocol, it really acknowledges the different types of relationships that you can have between these devices that may or may not perform routing. So you've got, at the fundamental level, you've got a stateless device that simply takes and forwards based on some information in that initial setup, and it'll always send it to the same place. It's a stateless device. You've got potentially a transaction stateful device, and that's responsible for setting up this association between the endpoints, and then it steps out, and it allows those endpoints to then communicate directly. Or you may have a dialogue, a full dialogue stateful, or session stateful device then that will establish the dialogue and then be part of that following. So the session border controller typically, as I said, it tends to be on the side of a stateful device because you've got all the advantages of topology hiding, and really the whole point is that you're directing your traffic through that for the life of the call. But that routing decision can take place up front one time, and then you can establish the relationship between these two endpoints. You can do the rerouting all up front, and at that point you can have this sort of transaction engine step out of the call flow.
Gene, you want to comment on that?
One thing I wanted to kind of add to this is a little bit off the topic, but I think we saw a little bit of it in what Gerhard talked about earlier in his announcement. What we've talked about here, I guess, starting at the very beginning, you had everything all in one box. You had your call signaling and you do your routing there. And as people started to need more sophisticated routing, more of it gets moved off on an external platform. It's really more tied to the OSS and the operation support, billing support system driven by least cost routing and other policy factors. But I think one thing that even takes us that we're going to see in the future is, there are multiple databases out there. So we started in the beginning, the routing database is in the signaling platform. Now we're talking about the routing database is driven by policy factors. It's on an external platform. Kind of we talked about the service control point, whether it's following roaming or it's least cost routing or whatever. There's different policies. But I think what we can see going forward is that platform is now going to have access, or we'll see the future's access to other routing databases. And I think we're all familiar with local number portability. You've got an enum database, you want to go check. You'll hit the local number portability database to understand, what is the real number that's been translated to. And I think when we start looking at what, was defined earlier, kind of this model that VPF has, start talking about segmenting different enum databases. You've got kind of groups. One thing looking forward going in the future, this isn't going to be the only platform like this. If the VPF is really successful in what they do, we're going to have groups of these large peering networks. And so what there's going to be is when a call gets routed, and this is really being driven a little bit kind of, if you're familiar with the GSM IPX, GSMA IPX architecture, really multiple networks that are interconnected where you have a call that goes from kind of one group of users, a group of carriers, that gets passed through perhaps several different networks in transit, and you have cascading settlements. And so the point I'm getting at here is just that not only is routing decoupled from the signaling device to a kind of an intelligent routing platform, but then that platform, we think, will make queries out to other networks. It doesn't have every possible route in its network, but it knows of other peering networks that could route that call, and it'll query them. So it's not going to be one enum server in the sky that has all your routes. I'll check this enum server, does it have a route? No, does it or does not? I'll check another enum server to find out if there's a federation of these peering networks and how to route the call. So that's just a little bit of a side, a little bit off the topic, but just, I think what we're starting to see that how the world is going here is this is not just a hierarchical point of view, it's more of kind of a mesh where there's going to be routing distributed between these networks, and really the kind of the peering mechanism is going to be the routing databases are going to have communication with each other to discover the route discovery between these different groups of routing networks, peering networks.
So what you're saying is essentially it's just the physical separation of the logic, right? What you're doing is, any databases that could do LCR or enum, they are basically stateless devices, right? So from architecture perspective, I have to initiate a query from a stateful device like SBC, get a response, and then go ahead with whatever the response is. So in that case, logically looking at it, the intelligence is still with SBC, just that physically the load is kind of offloaded into these databases.
Absolutely. And I think that there's no doubt about that. I mean, the load is for all the logic, whether it's least cost routing or beyond, is offloaded to an external database.
So it's just the physical separation, but I mean, if I look at my architecture logically, it's still my SBC which is doing the routing, right?
Yes.
So we have not really decoupled.
Well, something has to route the call. Something has to manage the call. And clearly, the SBC is at the path of that call. Right?
Yeah.
How about soft switch routing the calls?
Sure, that's it could be another device like a soft switch that you send a call to, and it redirects or places the call outbound as well. But even though you're using an SBC that may not recognize the DNIS or the ANI, it's relying upon somebody else to do that. It's going to be told what to do, and maybe it will do failovers, alternate routing, mission control. It might look at it and say, the person you told me to go to is, I don't want to send that much traffic there, I'm going to go somewhere else. So it depends how you break out the logic, but there's certainly a stateless part that is just a lookup, and then there's a more stateful part that takes into account the number of calls going to that location already or something like that.
So there have been some.
So if you look at it in terms, you've got a class 4, class 5, think of that in those terms, right? You've got subscriber information on class 5, some switched access, it's called LERG information on a class 4, international on the further upstream. So if you look at what happened when we started to overlay these concepts onto an IP network, what happened was we had a lot of reachability between these devices that were previously restricted really by network topology, right? Class 4 and class 5, and just the build out of the PSTN and circuit availability restricted the amount of information you had to store on any one of those types of devices. But now as we sort of flatten out the reachability, what happens is now you've got call it different trunk groups or different associations between endpoints, and what happens is you've got some set of reachability on one association, some set on another, and what happens even on a soft switch is that translation table becomes very large. There's no reason to consider really locating these huge translation tables on another device that's going to have a lot of reachability on the horizon. Really that type of data should be decoupled, but once you do that query, and we certainly want to be careful not to get into then a cascading query situation. The session border controller can certainly help filter that down to the appropriate set of queries. Maybe it's a bronze, silver, gold service, and you query the bronze database, for example. But also, you also have to think about the type of data then that we need to be able to extract from the